We'll see the diversity and the distribution of this family. Okay. This family Annonaceae is commonly called as a custard apple family, and this family is widely distributed in the tropical regions of the world. What are the tropical regions? Tropical regions are those regions where the temperature is normally high, okay, which is very close to the equatorial regions, okay, tropical regions. And some genera are also found in the temperate climates. Temperate climates are those climates where the temperatures will be generally less, okay. So these Annonaceae family members, they distributed in the tropical regions as well as in the temperate climates. And this family contains as a whole 130 genera, which includes 2,300 species all over the world. Okay, and in India, it is represented by 26 genera and 129 species. And in AP and Telangana, from where I hail, I belong to Telangana. So in AP and Telangana, it is represented by 6 genera with 13 species. And the largest genus is Gutteria. Gutteria is the largest genus with 250 species. Type genus is Annona. Okay, the type genus of this family is Annona. Now we will see some of the familiar plants which belong to this family. Okay, Annona squamosa, we call it as a custard apple. Okay. In my language, it is Sitafalamu. And Annona reticulata, a common custard apple, we call it as Ramafalamu. Annona maricata, we call Lakshmana Falamu. Annona cherimolia, mill, we call it as Hanuman Phalam. And Artaportris odoratismus, commonly called as climbing lang lang. Okay. In our language, we call it as a Tiga Sampange. And Kananga odorata, which is commonly called lang lang, and this is Chettu Sampange. And Polyalthia longifolia, the common name is mastery. We also call it as Indian fir, and in Telugu language, we call it as Naramamidi or Ashoka, false Ashoka. Okay. Then Nona discolor, we call it as Lavender Champa. The other common plants of this family are Uvaria purpurea and Monodora myristica. Now we will see the pictures of these members. Okay, see, this is the Annona squamosa, and this is Annona reticulata, which are edible. Annona squamosa, Annona reticulata, Annona maricata, Annona cherimolia mill. All these are edible fruits of this family. Okay, so this is Annona cherimolia. This is Artabotrys odoratismus. This is Canenga odorata. Polyalthia longifolia, which looks like Saraka Ashoka. We falsely think this to be Ashoka, but this is not Ashoka. This is Polyalthia longifolia. Okay. Then this is Uvaria purpurea, Nona discolor, and Xylopia aromatica. These are some of the important plants of this family. And this picture shows that the Artabotrys, the inflorescence of which in which the peduncle is modified into a hook-like structure, which helps in climbing. This is a liane woody climber, so it has a beautiful peduncle, which is modified into a hook-like structure. You can see here. Okay. So these are the important plants of this family. Now we will see the habitat, etc. Okay. The first one is vegetative morphology. In vegetative morphology, habitat. All these plants are mesophytes. You may be well known about mesophytes. The habitat denotes where they live. Okay, so the mesophytes are those plants which will get ample sunlight and water. So these plants are mesophytes. And regarding the habit, these plants are some of them are trees such as Polyalthia and Kananga. These are trees and shrubs, Annona squamosa and Annona species, other Annona species, they are shrubs. And some of them are also lianes. Lianes are nothing but woody climbers. Okay, so Artabotrys, Unnona, Uvaria, etc. are woody climbers. They climb with the help of the hook-like structure. You can see here the hook-like structure, the beautiful hook. Okay, so some of them are lions. In habitat, we say about the place where they live, and in habit, we talk about the nature of the plant. Either is it a tree, is it a shrub, or is it a lion? Okay, so here it is a this family includes both the trees, shrubs, or lions also. Okay. Then, in after habit, we have to discuss the root system, the shoot system in vegetative model. First, we will see root system. So the root system is taproot system. All the dicotyledons have taproot system, uh, and tetramerous or pentamerous distribution is seen. And this one, what you call merosity, is tetramerous or this pentamerous, and venation is reticulate venation. All these characters belong to this dicotyledons. Okay, regarding the stem is aerial, erect. It is well branched. It is woody, hard, solid, cylindrical, and the branching may be monopodial or sympodial. Now you have to understand what is monopodial and what is sympodial. You can see the monopodial branching in Polyalthia. Monopodial branching means the stem, it develops from a single apical bud. See, it is a continuous one. It develops from a single apical bud. Then such type of stems we call it as a monopodial. And the best example is Polyalthia. And in Arthropods, we see the branching is sympodial. Sympodial means see the further growth of the stem or branches, they occur from the lateral buds. See, this is the apical bud which stopped its growth here, and the growth of the stem again continued by the lateral bud. Here also it stops growth and the lateral bud continues growth. Okay, in such case, we call it as a sympodial stem. Okay, so the stem may be monopodial or sympodial. Regarding the leaves, leaves are exstipulate. What are stipules? Stipules are the green color small outgrowths which are present on either side of the petiole. You can see here a leaf contains a petiole and a leaf lamina at the base of the petiole. If a small structure, scale leaf-like structures are present, then we call them as stipules. So here stipules are absent. If stipules are absent, we call it as exstipulate. If stipules are present, we call it as stipulate. But in this family, the leaves are exstipulate and they are alternate. You can see here from each node only one single leaf develops. Okay, so the leaves are alternate and they have petioles, so they are petiolate. They are simple leaves, they are not the compound leaves. You can see here the margin is entire, so these leaves are simple leaves, and the shape may vary from ovate to lanceolate, and sometimes they may be obtuse. You can see here the tip of the leaf lamina, if it is blunt like this, we call it as obtuse leaves. Okay, so the shape may be ovate to lanceolate, and the tips may be acute or obtuse, and the venation is reticulate venation with a unicostate veins. Okay, unicostate means only one single prominent central vein is there, and it gives rise to many branch structures. Okay, so the venation is reticulate venation with a unicostate vein. Okay, then the leaves are also gland dotted and aromatic. If we crush the leaves with our hands, we can easily smell the aroma of that leaves. Okay, so this is the vegetative morphology of this family, Annonaceae. Okay. First, investigative morphology. What we have to discuss first regarding the habitat. Habitat. These are mesophytes. Habit. In a habit, we will say how this plant looks. Either it is a tree, it is a shrub, or it is a climber, or it is prostrate. Okay. So all these things we have to discuss in a habit. And then comes the root system. Root system is taproot system, and the stem. Stem is aerial, erect, branched, woody, hard, solid, cylindrical, and the branching is monopodial or sympodial. Okay, these terms you need to understand: monopodial and sympodial. If the stem develops from a single bud, okay, then we call it as a monopodial branching. But if the terminal bud ends up its growth, and again the growth continues by the lateral buds, then such type of branching is called sympodial branching. So both the monopodial and sympodial type of branching is seen in this Annonaceae family. And with regard to the leaves, we discussed that they are exstipulate, no stipules are seen. You can see here these leaves are without stipules. Stipules are the outgrowths, green color, small outgrowths. Okay, so these leaves lack this stipule, so we call it as exstipulate. And the leaves alternate. They have the petiole. They are simple, and the shape may range from ovate to lanceolate. Sometimes they may be acute, or sometimes they may be obtuse. And the venation is reticulate venation with a unicosted pinna, that is only one single prominent midrib is present, which gives rise to a number of lateral veins. And the leaves are gland dotted and aromatic. This is regarding the vegetative morphology. Now we will see the reproductive morphology. In reproductive morphology, we have to discuss about inflorescence first, then we have to discuss the flower, then flower in detail. All the four holes of the flower we have to discuss in reproductive morphology. So we will see the inflorescence of this family. It is a cymose inflorescence. What is cymose inflorescence? Cymose inflorescence, you might have read in your lower classes. Cymose inflorescence is nothing but the growth of the peduncle is definite. It ends up in a flower, and the uh, other flowers they come from the base of this terminal flower. Okay, in racemose type of inflorescence, you have indefinite growth of the peduncle, and all the flowers they are arranged in acropetal succession in racemose inflorescence. But in cymose inflorescence, the peduncle ends up in a flower. It shows a definite growth, and the flowers which arise later, they come from below the uh, terminal flower. Okay, so uh, these plants show cymose inflorescence. The flowers may be solitary. The other flowers may not develop. You can see in this diagram, the at the terminal region, it ends up in a flower, and the other birds you can see here, they arose from base of this uh, flower. Okay, this is cymose inflorescence. Here you can see that basipetal succession. Basipetal succession. And in artabotrys, you can see here, it is leaf opposite. Leaf opposite means what? Opposite to this leaf, the inflorescence arises. And here in artabotrys, as I said earlier, the peduncle is modified into a hook-like structure, which helps in climbing. Okay, which helps in, I mean, you can see here very clearly, the peduncle is modified into a hook-like structure. And in polyalthia, you see cauliflowery. What is cauliflowery? Cauliflowery, you can see the flowers which rise directly on the stems. Okay, cauliflower is nothing but the flowers develop on mature stems. So in polyalthia species, you see cauliflower. This is regarding inflorescence. Inflorescence is cymose, solitary or fascicles of two or three flowers may be seen. Okay. So then flower in detail. Flower. Then the flowers are bracteate. What are bracts? As we said, that stipules regard to leaves. The external outgrowths which are present at the base of the leaf are called stipules. In the same way, the flowers do bear some external outgrowths which look like very small leaf-like structures. Okay, these structures are called bracts. If the inflorescence bears back, we call it as bracteate, and if individual flower bears the bract, we call them as bracteoles. Okay, regarding inflorescence, we call them as bracteate. At the base of the peduncle, if the bracts are present, then such inflorescence is called a bracteate inflorescence. And if the flowers, the individual flowers, if they bear these bracts, we call them as bracteoles, the smaller sense. Okay, so bracteoles, if their bracteoles are present, we call it as bracteolate. In this family, these inflorescences they bear bracts, so the inflorescence is bracteate, and the flowers bear pedicel. You can see here, this is the pedicel. Individual uh, stalk of the flower is called pedicel. The stalk of the inflorescence as a whole is called peduncle. Okay, this is the peduncle. The whole thing is peduncle. On the peduncle, a single flower is developed. So this is pedicel. Okay, so they have pedicels. individual flowers, and these flowers are complete. What do you mean by complete? That means these flowers bear all the four holes, that is calyx, corolla, androecium, and gynoecium. If all the four holes are present, then we call it as a complete flower. And these are actinomorphic, and sometimes in some plants zygomorphic are also seen. Okay, what is actinomorphic? Actinomorphic flowers are those flowers which can actually this actinomorphic and zygomorphic is nothing but the symmetry of the flower. Okay, this actinomorphic are nothing but it shows the radial symmetry. We can cut a flower into two equal halves in any plane. Okay, such type of symmetry is called radial symmetry or actinomorphic flowers. And some flowers are zygomorphic also, um, due to unequal petals. Example is monodora. In monodora, the petals are of unequal size, so we cannot cut this flower into two equal halves in all the planes. Okay, it can be cut into two equal halves in only a single plane. Such type of symmetry is called zygomorphic symmetry. If it is not possible to cut into two equal halves, then we call that flowers as asymmetric flowers. Asymmetries, we cannot divide the flower into two equal halves in any plane. If we cut the flower into two equal halves in a single plane, then we call it as zygomorphic or bilateral symmetry. Only it can be made into two equal halves only in one plane. And actinomorphic means we can make the flower into two equal halves in any plane. Okay, so this indicates the symmetry of the flower. So here in this family we have actinomorphic flowers as well as zygomorphic flowers are seen in monodora. Okay, and these flowers are bisexual. Bisexual means both male and female flowers. Both male and female reproductive organs are present in the same flower. Okay, so these are bisexual flowers. And merosity is trimerous. Trimerous means merosity means these a number of sepals and petals and the essential organs, that is androecium and gynoecium, if they are present in three number or the multiple of three, we call it as trimerous flowers. Okay, so here these flowers are trimerous. Actually, this trimerous condition is seen in monocotyledons, but here, even though it is a dicotyledon, this family shows trimerous merosity. Actually, this trimerous is seen in monocotyledons. All the dicotyledons are tetramerous or pentamerous, but in this family we see the trimerous condition. Okay, so here the flowers are trimerous and they are hypogynous. What do you mean by hypogynous? Hypogynous means all the other floral parts they develop from below the gynoecium. Gynoecium is superior, and from below the gynoecium, all other floral parts such as stamens, petals, and sepals they arise from below the gynoecium. Okay, and the thalamus is swollen, conical, or elongated. Thalamus is seen. This is regarding the flower. Now we will see the flower in detail. In detail means we have to explain each and every hole of the flower. The outermost hole is called calyx and it is denoted by K. Okay, so as we said that the merosity is trimerous. Here the sepals are three in number and they are polysepalous. You can see here polysepalous means these sepals are not united. If they are united at the base only. Okay, see at the basal region, they are connate at the base. Connate means they are attached to each other at the base region. And the merosity, this estivation is valvate estivation. Valvate means just touching, no overlapping is seen. These sepals are just touching each other. So such type of estivation is known as valvate estivation. Sepals are three. Polysepalous condition, that means they are not united. Okay, if they are united, we call them as gamosepalous. Here, it is polysepalous. Sepals 3, polysepalous, and they are connated the base. Okay, and the estivation is valvate estivation, just touching, not overlapping. Okay, this is regarding calyx and corolla. Petals are 6 in number, 3 plus 3. The petals are arranged in two holes. Outer hole has three petals and the inner hole has three petals. Okay, so polypetalous condition, 3 plus 3 conditions. Sometimes inner 3 petals they may reduce or they may be absent. Okay, in Annona squamosa, you can see that these petals are sepaloid in nature. Sepaloid means they are green in color. They look green in color. Just we may consider we may think these petals are sepals sometimes because they look like sepals. They're green in color. And the estivation here also it is volvata. Sometimes it may be imbricate also in some flowers. In some other members of this family, the estivation may be imbricate. Imbricate means one sepal or petal is completely in the uh, petal which is opposite to that is completely out, one in one out, and the other three petals they may be their edges may be one edge inside and one edge outside. As such type of estivation is called imbricate estivation. So the estivation may be volvate or imbricate in this. Okay. Then coming to the essential organs, these calyx and corolla are called non-essential organs, or sometimes if no differentiation is seen, we call it as a perianth. Okay, undifferentiated outer holes. If they are present in a single hole, or if they look like the sepals or petals. Okay, sepals and petals we cannot demarcate. Okay, they look alike. In such case, we call them as perianth. Okay, non-essential organs. These are essential organs. Essential organs are androecium and gynoecium. The reproductive organs are called essential organs. In androecium, usually the stamens are indefinite. Indefinite means many in number. In Orophia zelenica, there are only 6 stamens. Otherwise, all the other members have indefinite number of stamens. Okay, and the stamens are present on the lower side of the thalamus, and they are arranged spirally over the thalamus. You can see here, this is the thalamus. Okay, this thalamus. Over this thalamus, these stamens are arranged spirally. They are indefinite in number. The filaments are very short. You can see here the filaments are short, and they are stout. And anthers, these are dithecous. Anthers are dithecous, and they are adnate with the filament. Adnate means throughout their length they are attached to the filament. Sometimes you can see here the connective overgrows over the film, these stamens, and it looks like a hood-like structure. See, this is the connective which is grown over the uh, anthers, and it forms a hood-like structure. So this is regarding the uh, androecium. See, the stamens are dithecous in nature with a short and stout filament, and this hood-like structure is the connective. Hmm, this connective overgrown over this anthers and forms a hood-like structure. This is regarding androecium. Okay. So next comes the terminal, the uppermost part of the flower is gynoecium. So the gynoecium carpels are many, and these are also arranged on the raised receptacle in polyalthi and arthropods, and carpels are only 1 to 3 in a cyathocalyx. They are apocarpus. Apocarpus means they are not united. If they are united, we call them as um, syncarpus. All of them are united and form a single structure. We call it as syncarpus. But here you can see they are free. So apocarpus, and the ovary is superior, that is in hypokynous condition, as we discussed earlier. All the other parts they develop from below the ovary. So the position of the ovary is superior. So superior ovary, unilocular condition is seen, and one to many ovules develop in the loculum. Parietal or basal placentation. Placentation is the attachment of the ovule inside the ovary with the help of placenta. Okay, so this placentation may be parietal, or it may be basal, or it may be marginal placentation. Okay, stigma is sessile and simple, or it may be trilobed. See here, the stigma is trilobed, and the style is very short in nature. Okay. Actually, what is a carpel? Carpel is nothing but it's a female reproductive unit. Okay, carpel is a female reproductive unit which bears a style, stigma, and ovary. These three parts are present in a carpel. It is a female reproductive unit. Number of carpels may be present. Either they may be free or they may be uh, combined. Okay, if combined, we call it as syncarpus condition. If they are free, we call it as apocarpus condition. In syncarpus condition, all their um, stigmas, styles, and ovaries may be fused in syncarpus condition. But in apocarpus condition, we have individual, each carpel is uh, free from other carpels. So here we see many number of carpels arranged spirally over the raised receptacle. Okay. The apocarpus condition and the superior ovary which is unilocular with parietal, basal, or marginal placentation. Okay, stigma is very uh, uh, the style is short and the stigma is trilobed in condition. Then next comes the pollination. Pollination is by insect. Insect pollination is seen because they have attractive flowers. So these flowers attract the insects, and pollination is carried out by these insects. Fruit. Here the fruits are aggregate fruit. Aggregate fruits are nothing but merging of number of ovaries in a single flower. See, uh, we have the carpels are many in number. Each carpel develops into a single fruit. Each ovary has ovules inside, and when it is fertilized, each ovary develops into a fruit. So we have number of carpels, so number of fruits are developed, and all these fruits they are merged. Okay, merging of the number of ovaries in a single flower results in the formation of an aggregate fruit. Each and every structure, this one, okay, a black seed is present inside this, covering with a fleshy white colored pulp. Okay, so each such a thing represents a single carpel. So all these carpels are these are united inside a single flower and form a aggregate fruit. Okay, and mm, in Artabotrys and Polyalthia, you see this fruit as uh, aggregate of berries. See, these are in, you can see here all these fruits. They represent a berry, each one, and we see here the aggregate of fruits in Artabotrys and Polyalthia. And in Monodora, only one simple fruit is seen in Monodora. And this one is a floral formula. You can see what is floral formula. We have to define the complete flower with the help of the symbols. Okay, so BR represents bracteate. We said that these are bracteate. That means they possess the bracts. It is this circle with plus sign. It denotes its symmetry. We said that these are uh, what do you say, symmetrical flowers, that is actinomorphic flowers. So bracteate, actinomorphic. This one is a bisexual flower. The arrow mark denotes the male reproductive organs, and the plus mark with this circle shows it's the female flower. So okay, if we denote it with both of this, then it is a bisexual flower. That is, it bears both androecium and gynoecium. Bracteate, actinomorphic, and it is bisexual. K3 means calyx is 3 in number, and it is polycephalous condition. If we put these 3 in brackets, then it denotes that it is gamocephalous. But here the condition is polycephalous, so we are not keeping this 3 inside a bracket. Okay, if at all they are gamocephalous, we have to denote it inside the bracket. So calyx is 3, uh, polycephalus. Corolla, it is 6, present in 2 holes, 3 plus 3, and they are also polycephalus in condition. Androecium, the stamens are infinite in number, so we are showing the infinite number, and the gynoecium, they are also, the carpels are infinite number, and ovary is superior. Superior ovary is all the other parts develop from below the ovary. So we have to put the ovary on a dash symbol. Okay, so this denotes superior ovary or hypogynous condition. This is regarding the floral formula, and this is the floral diagram. A schematic representation of this floral formula is a floral diagram. You can see the outermost hole. It has sepals 3 in number and a polycephalus in condition. The inner two holes you can see here. This denotes the um, petals in two holes, and they are also polycephalus in condition, followed by number of stamens. Okay, these are stamens, infinite in number, and these are carpels. There are also many. Okay, this is the floral diagram, and finally, the economic importance of the family. In this family, the plants like Annona squamosa, Annona reticulata, Annona maricata, and Annona cerimonia mill, and Asimina triloba. These are grown for fruits. Okay, this the place from where I hail, Mehbubnagar, is very famous for this custard apples. Okay, it is a hilly area, a lot of hills are seen in this area, and these plants, they love the climate here. Okay, so you can see a lot of these plants grow all over our district. Okay, so our district is famous for this custard apple. We love eating custard apple. Then some of these plants are also ornamentals. Polyalthia longifolia, which we said that this is false uh, Ashoka. Okay, Polyalthia longifolia is a false Ashoka, and Polyalthia pendula and Desmos stridensis, these are ornamental plants which are grown in gardens. And Kananga odorata and Unona discolor, they are grown for the scented flowers. You can see here these flowers which are scented in nature, and perfumes are prepared from these flowers. Kananga odorata and Unona discolor. Okay, and the seeds of Monodora. See, this is the inflorescence of Monodora. These are the seeds of Monodora, and the fruits of Xylopia aromatica. See, these are the fruits of Xylopia aromatica. This is the inflorescence, and these are the fruits of Xylopia aromatica, and this is the flower of Cananga odorotismus. Okay, all these are used for making perfumes. They're sweetly scented, so they are used for making perfumes. And recording medicines, leaves, bark, roots of Annona squamosa are used as disinfectants, and they're also used for clearing the dandruff and the remove lice also. We have to crush the black color seeds and we have to apply to the hair, then it will remove the lice and it also clears the dandruff. Okay. Then some of the plants such as Melusa velutina, the leaves of which are used as fodder for cattle. Okay, so these leaves they are used as uh, fodder for the cattle. Melusia velutina. And the last one is Xylopia parviflora. Here the timber is used to make lightweight furniture. Okay, Xylopia parviflora, lightweight furniture, and the timber of polyalthia is used for making boxes. Okay, and also pencils and matchsticks. Okay, so this is regarding the economic importance of this family, and at last. Once again, we will see the salient features of these plants. Plants are mostly woody trees, we said. Leaves are simple, alternate, extripolate, and distichous condition is seen. And flowers are solitary, hypogynous, and trimerous. Sepals 3 show valvate distribution. Petals 6, 3 plus 3 in condition in 2 holes. They are also valvate imbricate in condition. Stamens are many, are indefinite in number, arranged spirally on thalamus. The carpels are indefinite. Apocarpus in condition, arranged spirally on the thalamus. Thalamus is a conical or elongated. Fruit is aggregated or iterary of beraceous. Okay, so these are the salient features of this family, and a systematic position as per Bentham and Hooker, as these are flowering plants. They are they are placed in the division phanerogams. Okay, seed bearing plants or flowering plants are placed in phanerogams. And the class is dicotyledonea as these plants show taproot system and reticulate venation. I said that the tetramerous and pentamerous condition belong to dicotyledonea. The dicotyledonea show taproot system. Tetramerous or pentamerous condition, and the venation is reticulate. But here in this family, we see trimerous condition, which is usually seen in monocotyledons. Okay, but in this family, Annonaceae, even though it belongs to dicotyledonea, the merosity is trimerous, which is unlike to all other dicotyledons. Okay, so they are placed in dicotyledonea because of presence of taproot system and reticulate venation. Okay, and cotyledons are two in number, but the except the merosity is trimerous. Okay, then polypetale, because the sepals and petals are free in so they are placed in polypetale. They are not fused; they are free. Petals and sepals are free, so they are placed in polypetale. In thalamiflorae, the thalamus is conical. Okay, flowers are hypocynous. Thalamus is conical, so they are placed in thalamiflorae. And the order is Ranels. Ranels order shows many corpels and many stamens. Okay, indefinite number of stamens and indefinite number of carpels are arranged spirally over the thalamus. No? That's why this family is placed in the order Ranels. Okay. And the family Annonaceae, leaves alternate, extricate, thalamus conical or elongated, stamens many, corpels many, apocorpus, all these include in Annonaceae. So this is today's class. Hope you enjoy. Uh, Thank you very much for uh, listening.